As an ML researcher, your products are papers. Essentially, you're selling an idea, you're selling a story, you're selling a narrative. You're hoping it sticks in the market. And for it to stick means people understand it, and then hopefully they cite it later. It changes their own mind, it changes their own research trajectory, and you get in exchange citations. The metric is popularity.
Yeah.
In the other world, the more product-based world, you're selling products. Your products have to work. They have to bring value to someone, to some customer. The metric is revenue, not popularity. Like there's many successful companies out there that you've never heard of because the popularity doesn't matter to them.
Hello, everyone. Welcome to the Data Scientist Show. Today we have Jason Yosinski. Jason is a founding member of Uber AI Labs, where he was working on fundamental deep learning research. He is the co-founder at ML Collective, an independent nonprofit organization that supports open collaboration in ML research. In addition to this, he is also a co-founder of Windscape AI, a company dedicated to using custom sensor networks and machine learning to increase the efficiency and sustainability of wind farms. Jason holds a PhD in computer science from Cornell University. Today, we'll talk about his experience at Uber AI, his research in deep learning, and ML for wind farms. If you enjoyed the show, do me a favor, subscribe to the channel, give me a 5-star review, and leave a comment if you're on YouTube. Welcome to the show, Jason.
Thanks. Happy to be here.
So, how did you become a research scientist at Uber?
Well, that's a long story. In 2009, I had a different company, which was failing, and I had a quarter-life crisis, and I was thinking what to do with my life, and I realized I like tinkering with things. I like messing around. I like messing around with complicated systems and figuring out how they worked. And I could see my future as someone with basically a garage and an oscilloscope and like welding equipment messing around forever. And I didn't want to just do that in the middle of Oklahoma or wherever. And I thought, okay, well, I could be a scientist and basically do the same thing, but sort of legitimately.
Yeah.
So I decided to be a scientist. So I went to grad school, did my PhD, got into machine learning, got into neural networks, had a lot of fun years messing around with neural networks, improving them in different ways. After grad school, I joined up with some friends who were working on a company in New York City called Geometric Intelligence, and fairly quickly Uber bought us, and we all moved out to SF and started Uber AI.
Oh, okay. So Uber acquired the company you were working at.
Yeah, that's the second last step. Yeah.
Yeah. And so after your company got acquired by Uber, what were you working on at the Uber AI lab?
So at Uber AI, this is back in late 2016, early 2017. Back then, so a lot of the big players, Microsoft, Google, I can't think on my feet while being recorded, but all the big players had AI labs internally. The biggest five, maybe NVIDIA, right? Baidu had a lab. But a lot of the other companies didn't have an AI research group internally. And all the companies were seeing that, of course, the value of data is increasing, the volume of data is increasing, the need for machine learning and AI to process data is increasing. And there was a problem of just getting started because none of the ML researchers wanted to work at a company where there were no other ML researchers. So it was sort of a chicken and egg problem. So the reason we went to Uber was to start Uber AI and kind of bootstrap. Day 0, no group. Day 1, there were 14 of us. Day 30, day 60, we started hiring people and kind of building out the group.
So when you started Uber AI Labs, did you have a specific problem you wanted to solve, or you were building the deep learning infrastructure?
Right. So our vision for AI Labs was to do two things. One was to continue pushing fundamental scientific advances forward, the same as one might work on in grad school. So publishing papers, going to conferences, presenting, just doing the scientific process. And the second half was to pull the most recent scientific advances, not only from our group, but from the much broader community, into the company and help get the most modern methods into production as quickly as possible. So we sort of started building both halves of that. I worked much more on the science half, and a lot of other folks worked on the infrastructure side, the engineering side, the applied ML side.
Yeah. So it sounds like part of your work can be more exploratory. You do research, follow some interests, but you do need to bring some state-of-the-art research into the production. So how did you balance the pure scientific research versus translate that into like business value?
Yes. I don't think I personally balanced all of that myself. It was more
Yeah.
like there are many people in the team and people were deployed in different ways to affect different components of that balance. I mostly was on the science side. I did try to help out a tiny bit with real stuff inside of Uber via what we called ML office hours. My friend Rosanna and I started this thing called ML office hours. We would basically go once a week to some conference room and it was open invite. Whoever wants to can show up and we just talk about ML papers, ideas, could be research, but more often product directions. So-and-so is trying to integrate ML to ingest this type of data to predict something about customers and they're wondering what losses they should use or why their model doesn't train or why it performs well here and then they deploy it in a different city and it fails completely, for example. So we tried to basically just create a space where people could freely talk about this type of stuff. And I kind of joke that after a year or two of doing that, I could essentially have replaced myself with just a sign that I put on the desk and that don't even show up. And the sign just says, don't use regression, use classification, because not everything's Gaussian. And just define your metrics. What do you care about? Define your metrics and then test your metrics. That's how well your thing works.
That's kind of the answer to most frequent asked questions.
Yeah. If I had my own Stack Overflow, it would just be 2 questions. It would.
Oh, interesting. What are some other best practices you usually suggest?
I don't know. I don't have a long list. I think it's surprising to me how often the metrics one comes up. People that I talk to at Uber, but also many other people at many other places, it's common to have cool ideas, crazy ideas. What about this model? This model might work better. I think this idea should be promising. And people kind of discuss and argue on the level of which idea sounds more cool or new, but then they're not grounded in anything. It's just an idea discussion. So to really ground things, you have to figure out what do you actually care about. If I come to you with my model and you come to someone else with your model and you say, look, tell us which model's better.
Yeah.
How are they going to answer that question? That's the question you really need to think about kind of up front.
Right. Yeah, because when we learn in school, we measure model by like accuracy, precision, recall, those metrics. But when you put a model in production, you want to think about the cost. Sometimes it's the speed or maybe some specific business metric only your team defines. So you need to decide what is important for you. Otherwise, there's no way you're going to measure whether your model is useful.
Yeah, totally. A lot of people getting into machine learning, and I guess now we're talking more about machine learning than data science, but a lot of people getting into machine learning, the first place you start is with any of the number of standard data sets. You download the data set. It has a bunch of features, maybe a bunch of images on the one side, a bunch of classes on the other side. You train the model to go from one to the other. The loss is just how well you do on these labels, and the metric is how well you do on these labels. And it's a very well-contained little tiny microcosm, right? But the real world is never like that. Oftentimes you train with a loss or train with a temporary sort of training metric, and you care about that while training just to force the model to learn something. But then when you deploy it, you care about many other metrics which are downstream, harder to evaluate. Probably those metrics even live on different teams. So your whole team doesn't even have in-house the metrics that you care about.
Yeah. So if you pick a day, how would you describe your kind of day-to-day when you were a research scientist at Uber?
It was 70% like grad school. So just reading papers, trying to understand what direction the science is going, coming up with good questions to ask, and then strategies to answer them, research programs to answer them. And then 30% like what it's like to be in a big company stuff. So I don't know, meetings and perf and emails and calendars and all this stuff that I had no experience with before. Like actually the 14 of us showed up day one at Uber, got our laptops or whatever. And they told us something about needing to have like positions and roles, and we should all have a level. Yeah. And like I think no one on the team had even heard of the concept of a level. We're like, what's a level? Yeah. You want us to give ourselves a number? Like, can we just pick a number, or how does this work? Anyway, we slowly realized, or maybe pretty slowly realized, that these things are very important, and like this is how companies actually operate. Right. And people do promotions, and those are very important things. But yeah, for me, for all of us, it was a learning experience.
Yeah. Well, it sounds like a really cool position. When I work at Amazon, the research scientists, at least in my group, they still need to work on very practical problems. Their day-to-day is tied to very specific project. They're like deadlines. And also you talked about the level concept is new to you. That's my other question. So how do you navigate that, for example, or how did you get to the next level? Or I don't know, maybe you didn't care. Like what was it like for you?
Well, it took us in the group a while to kind of learn these larger corporate norms, but eventually some people helped us and we learned and we tried to move our organization closer to that structure. Did we care about it? I think many of the folks in our group who would identify as scientists cared more about their sort of standing and progress in the external scientific community than in sort of the internal company ladders and things. That said, I think this is all I'm describing a little bit of a bubble in history and machine learning. So this bubble where we had large companies paying a lot of money to have folks around tinkering around in science, publishing, but not always necessarily direct real world impact. It was great. A lot of us loved it, and science advanced a lot due to all these people's work. But I think that world is a little bit disappearing. You've probably heard about the hiring freezes across many parts of industry, in particular for researchers, because ultimately a lot of companies can't afford to just fund science. They need real world engineering and expertise and like real world progress. So I think it's a little bit of a bubble. It hasn't popped, but it's a shrinking bubble maybe.
Yeah. And does that group still exist in Uber?
Yeah, the group still exists. It's since I left 2.5 years ago now. It's probably mutated and changed in some ways, but yeah, Uber AI still exists. It's a little bit more product focused now than it used to be.
Yeah. And when I was researching your bio, your research was focusing on understanding how neural networks learn and represent information, how they break and behave in unexpected ways. Did you continue this research in Uber as well?
Yeah, definitely. A lot of what my sort of scientific career focused on is understanding models, understanding neural networks in particular, and how they work internally.
Yeah.
Like if you just, from an engineering perspective, you can try to build the world's best mousetrap or build the world's best neural network. You can also see neural networks almost as an organic external phenomenon, a thing, and you can study it the same way biologists might have studied plants or squirrels or something. You can poke at it and try to figure out how it works.
Yeah.
And the reality is of a lot of these models, and even more so today with these absolutely huge models we now have, they're so big and the computation that they learn inside is so complicated that it's hard or impossible to really understand what they're doing. But it's also important to understand what they're doing, because if we don't know what they're doing, it limits us in a couple of ways. First, when the models don't work, it's hard to know what to do to fix them if you don't even understand what's happening inside. If it's just this big soupy mess of linear algebra and sometimes it works and sometimes it doesn't, you might not know what to try. And then second, as models increasingly have sway over our society and affect our society and make important decisions that people care a lot about, if we don't understand our models, we have limited ability to ascertain whether they're in fact aligned with what we wanted them to do in the first place, right?
Yeah. So how did you understand neural networks?
Some of my early work in understanding neural networks was just plotting things, like run the networks, plot the activations, and slowly build up a casual intuition for what they're doing, maybe develop a theory and then test that theory and write it up in a paper. One of my old papers that I still like showing people is the Deep Viz Toolbox. So this is a really simple app you run on your computer. It takes images from your webcam, feeds it through a model, and you can like poke around the model and go using the arrow keys, go to any layer, and you can see what activations are firing on that layer. And as you move your head around or wave your hand or something, you can see activations moving around in the network, and you build up a very fast, very casual intuition for what's going on. And then you can start to dig deeper. Like for any given neuron, you can say, what is this neuron representing? And we pre-compute, we go back to the training set and we figure out all the times this neuron fired, what images, because this is an image model, made it fire the most. And we show all those images and you can say, this neuron must be detecting golf clubs or faces or clocks or something.
Yeah. Yeah, I see a lot of data scientists kind of adopt this into their day-to-day process. And what was the most challenging part when you were doing research trying to understand neural networks?
The fundamentally most challenging part, so the model I just talked about kind of prodding around was actually AlexNet. We used the original AlexNet for most of the work. which is tiny compared to today's largest models, but still it had 60 million parameters. So sometimes I say 60 million parameters, 60 million numbers. If you want to visualize 60 million things, I think it would take something like 30 monitors, all at 2 megapixels or each, just to have one parameter per pixel. So imagine these 30 monitors in front of you with all this like kind of salt and pepper noise on it, right?
Mm-hmm.
You can't understand what that is.
Yeah.
To understand 60 million of anything is very hard. Even if we talk about a neuron level or a feature level, at some layers of these networks, there's hundreds or thousands of neurons.
Mm-hmm.
I spent a long time, hours, poking around like a single neuron, just like seeing how it responded to different things. Like even I don't know in my own network, in my own paper, in my own study, more than 1% of the neurons in this network. Like it's just hard to get that information from the network into your brain somehow.
Yeah.
And the models these days are so much larger that it's a very hard task to start with.
Mm-hmm. Yeah. So it sounds like you had a really cool job at Uber. So what made you want to leave?
Well, two things. I had been a researcher for 10 years, 2010 to 2020, and I realized my mental model of the field is those 10 years we made a lot of scientific progress, and so many things were possible that weren't possible at the beginning. I have this hunch that the next 10 years will be a little bit different. The next 10 years, of which we're already 2.5 into, I guess, 3 into, will be more about scaling models and then applying them in industry. So I see people in grad school now, and it can be hard for them to compete with like the biggest models trained by companies that have tens of millions of dollars of resources to train them. So I kind of felt like the field was shifting a little bit. I also wanted something a little bit more applied. And at the same time, I got into climate change and started reading books about climate change. I got really interested in that, realizing we kind of need to do something now to make sure our planet is still here and like available for our children in the ways we want.
Yeah.
That's one reason. Second reason is Uber decided after the IPO that they could no longer afford to keep a bunch of scientists around just writing things on whiteboards.
Doesn't look good on the financial report.
and having their free lunches, I guess.
Yeah.
So without commenting too much about that, they decided to fire 35 of us, I think it was. Basically, they fired all the people that were working on publishing, and they kept all the people that were working on product.
Oh, okay.
Whether that's a good move or not, I won't comment. But in any case, the second reason is I was fired.
Yeah. Okay. And after that, how did you feel about that? Like, did I finally can have time to do some of my own research, or does it affect your life?
Yeah, I felt relatively okay. Like it was fine timing for me. I feel kind of lucky in that sense. A number of other people, it was fine timing for them. Not everyone though, but yeah, I was ready to kind of move on. So for me, I just naturally stepped into the next stuff, which for me was a lot of learning and investigation, and like I said, learning about climate change.
Yeah.
To learn, I read a bunch of books, and I also interviewed a lot of people. Probably talked to 150 people about their industry and the problems they worked on, and like.
Oh wow! How did you find the 150 people?
There's a lot of people around. I don't know. A couple of sources. So first, a lot of people now and a couple of years ago in tech in San Francisco in this ecosystem are interested in climate change. So there's a number of online communities, Slack communities of people that are just all learning about this stuff together. So highly energetic, highly interconnected, very open to talking about anything. That was one source. So I joined a few of those and had lots of conversations there. Another source is I ended up co-founder dating this one friend of mine named James. He was very good at setting up calls. He's very good at like this outreach, biz dev style stuff. So he set up a lot of calls with a lot of people, and we kind of did a bunch of these interviews together.
Yeah.
And then also I just met a lot of people along the way.
Yeah.
So I met this farmer, and we like had a little pilot project for his fields of his pastures and how healthy they were, so he could move his cattle around and stuff. And I forget how I met him actually. I think someone introduced me to him. I don't know.
So I think that's pretty impressive. Like you didn't just jump into the next project. You took some time to do your research and understand what problems is more important to solve and what is your interest. So how did you eventually decide to work on wind farms?
Yeah, so I spent a long time interested in things other than wind and other than energy, like carbon credits and farming, like I mentioned, the cattle project. Carbon credits, like monitoring forests and oceans, even like seaweed farming and stuff. And this trajectory, if you're getting into climate, a lot of people go through a similar trajectory. Everyone has like a seaweed phase, I think. And I have some good friends working in seaweed, I guess. I eventually read some of Saul Griffith's stuff. So he has a book called Rewiring America, and now he has a newer one. And he takes a scientific engineering approach to like top-down understanding of the problem of climate change. And I kind of bought it. I bought his analysis. It's pretty clear. It's pretty simple. And I can even summarize it for you.
Oh, yeah, that would be great.
There's roughly 1 billion machines on Earth that we humans use. Cars, factories, little things. Roughly 1 billion machines that operate using fossil fuels. And to get to net zero, we have to turn those 1 billion machines into electric versions of those machines. So like your furnace that is heating your house right now burns natural gas, maybe. We need to replace that with a version that uses electricity. So we need to turn all the machines into electric versions, Teslas, etc.
Yeah.
And then we need to generate all that electricity using clean means. So nuclear, wind, solar, and hydro. Some combination of those. We probably need all of them to succeed. And we need to turn off all the coal plants and the natural gas fired plants, the peaker plants. And then we'll have done it. We'll have a world that's 100% electric, or largely electric, largely carbon free. There's some like little details in the margins, like how do you deal with airplanes that still need to use fuel, and maybe you can make that fuel cleanly in a carbon neutral way by recycling the carbon and something.
Yeah.
But essentially, we need electric machines and clean energy. So if you want to work on the problem, if you work on one of those halves, it's quite meaningful. And we need hundreds of companies and tens of thousands of people working on both halves.
Yeah.
And so I decided to work on the energy half. And for the energy half, I started meeting people in wind and solar, and kind of gravitated toward wind, and also met the right co-founder, a friend named Eric Thompson, who has been in wind for 20 years. And we got along really well and decided to go for it.
Yeah. Cool. So now I want to get into details a little bit for our audience to understand. So what is the problem you're trying to solve more specifically? What do you try to predict? What is the data?
So we have in the US a bunch of wind turbines. Actually, almost 10% of US generation is wind turbines, which is, I was surprised how good it is already. When they operate, they use data about what the air is doing to make decisions about which direction to turn, about how aggressively to pitch the blades as they spin around to kind of catch the maximal wind. Actually, if you've ever been on a sailboat, if you've ever sailed, when you're sailing along, you'll kind of have the sail, and it's kind of in trim, and it looks really nice. It's like a perfect curve.
Right.
There's a little telltales in the front that kind of like stream backward, and you can tell it's in trim. And then if the wind changes a little bit, or you change direction, one side of the sail will kind of flap, or the other, and you need to change the shape of the sail to adjust for the new wind condition.
Like,
For example, when you drive, you need to make a lot of adjustments. So wind turbines need to do the same thing. They don't have sails that adjust with a line. They instead just turn the blades, and they turn their whole nacelle, the whole top of the turbine. To do this, they need to know what the wind is doing. And the way they know that right now is basically not very good, not very efficient. The data that they use is a bit dirty. We can talk about why. It's also a bit late. So they constantly are reacting to changes in the wind later than they should have. To be optimal, they should be reacting earlier. Like they should be predicting the future and reacting as early as possible in a sort of a more prescient way.
Yeah.
So now we have an intersection in our Venn diagram. We can affect the physical world. We can make more clean green energy by using better data and interpreting that data through ML models to kind of make sense of it all.
Okay. And for example, what kind of ML model do you use for this type of problem? Do you use neural network or regression?
We have used many types of models. We are constantly doing two things. We're constantly pushing toward more capable models, more competent models, but we're also constantly making sure we check our baselines. And like we don't need to build something more complicated than required. So we always start with the simplest baseline and kind of work our way up from there. Like, could we have just used linear regression for this? Could we have just used a two-layer network for this, and so on? And the best models now are a bit more complicated, but not too complicated.
Oh, okay. Yeah.
I think often in the real world, there's this like single canonical ML plot I have in my head at all times. So on the x-axis is like how much energy, how much you try, how much data you have, how big the model is, and the y-axis is like how well it works.
Yeah.
And like every ML plot is the same shape. It's like this keeps getting a little bit better, right? So when you have a startup that's as small and young as ours, you're trying mostly to get like up the first chunk of the curve as quickly as you can.
Yeah.
And then taking that to the customer and trying to create value and get to some revenue and like make something meaningful in the world.
Right.
And then on the weekends, if you want, or you can hire a bigger team later, you can spend a long time like marching up the final stages of that long curve. And someday I hope our company will be hundreds of people and we'll have a big ML team that can spend a lot of time like proposing really cool tweaks on models, twists on models, new models that help us march up that all the way up that curve. But for now, we're kind of in this part of the curve and we have some models that are not too complicated but do pretty well.
Yeah. So it's an art to find out when it's good enough.
Yeah.
And then previously we talked about metrics. So this is a new problem you're trying to solve. And when you started, did you know what metrics you want to use?
No, not at all. So for me, coming from academic ML, I had no idea how the industry works, nor what people care about, what our customers cared about, nor what work had been done by the many scientists who have worked in this field for decades.
Yeah.
But those scientists have published their papers. You can go read them. Essentially, we care about predicting the wind speed and the wind direction ahead of time and predicting it as accurately as we can.
Yeah. So you learned about the metrics through reading some papers and talking to people.
Yeah.
And,
but also what our customers care about. So that's an intermediate metric that we care about, we target. But what our customers care about is what is their revenue and what are the stresses and strains on their turbine when each gust of wind hits the turbine and knocks it back and it rattles around a little bit and bends. Integrated over years, that causes you to need to replace millions of dollars of components. If we can save them some rattles, then they care a lot about that. But like the amount of turbine rattling is not exactly the same as what is your RMSE for the wind speed, for example.
Yeah.
But we're working to kind of bridge that gap, and we're working with our customers to bridge that gap.
Yeah. And for this type of data from sensor, did you build the sensor or you build a sensor?
I have. I'll show it to you.
And for folks who are listening, Jason is showing us
Oh,
the
it's
sensor.
audio or some people?
It's okay.
You can
I can describe
what
it's
So
a
we
white box.
It's a white box. It's just that, yeah.
Yeah.
This is actually Gen 2 of our sensors, designed and built by our hardware guru named Lane.
Okay.
Here's the fundamental sensor. It's a pressure sensor that provides us with the data that we use to train the models. And a few other little chips that do various things. But yeah, we designed and built it ourselves, or rather Lane designed it and literally soldered this one together.
Cool. Thanks for showing us.
And we're constantly improving. We'll have a next generation with a few other bells and whistles. But
I think it's pretty cool that you have your own sensor so you can decide what kind of data you create. You don't need to rely on a third party.
Nobody had wanted to measure this kind of data because it wouldn't have been useful for anything. Actually, one kind of cool thing is the pressure sensor we use in that box is the same one you have in your phone or like smartwatch or something. So most smartphones have a pretty accurate pressure sensor. Pressure sensors have gotten better over the years because of the billions of smartphones that have been built. So nothing to do with the wind industry at all. But basically we leverage these much better sensors to create our boxes. So it's only recently possible that anyone could have built this, which is maybe one reason nobody did 5 years ago or 10 years ago.
Yeah. And when you just build a sensor and installed it on the wind farms, did you have enough data to build a model? How long, or did you use some simulation? Like how long did it take for you to gather enough data to build your first model?
It's just shades of how good the model is. So with a little bit of data, we can do a little bit well. With more data, we can do better. We did not start with simulations. We started with real data just because if we started with simulations, it would have taken a long time to get up and running. We actually have a collaboration with a university in that direction. But even if it worked in simulation, we would still need to prove it worked in the real world. And if it failed in simulation, we would still probably try in the real world just to see if there was a foothold in the real world that didn't exist in simulation. So we just went straight for the real world.
Okay, cool. Yeah, I think a lot of times when we work in the industry, the data set is never perfect. And sometimes data scientists want to see, I want to wait till I collect the perfect data to train my first model. But sometimes that might delay the project. I think a lot of times just use small subset of the data to train a model that can help you understand your data already?
No, absolutely, yeah. Always start small models, simple models, and small data sets, but then,
Yeah. And for this use case, is batch inference works, or do you need real-time processing?
We mostly think in terms of batch occasional training and real-time inference. Yeah. But our requirements aren't too extreme. Like the number of queries per second is nothing like Google's, right? So we don't anticipate that'll be impossible.
Yeah. And what is the most challenging part about building this solution?
Well, for me as a non-hardware person, like messing with hardware has been interesting. It's like guaranteed not impossible, but it's also not trivial. So it's somewhere in the middle. Like you have to put in the time to write good firmware and embedded software that does the right stuff, samples from the sensors in the right way. There's also completely out of band stuff. Like one of our sensors we put in a specific field a little ways away from San Francisco, and a couple months later came back and a cow had knocked it over because they found it. The solar panel, the edges are rounded, but they're like a rounded piece of metal.
Yeah.
And it found it useful to scratch on. So like I did not anticipate needing to build in like cow robustness to our sensors. But yeah, we should probably make them less attractive to cows.
Yeah. And from the machine learning perspective, previously you were doing a lot of research and now you worked on something more applicable. Do you find the model building part is easier compared to other challenges?
Yeah, I would say in academia or in the publishing context, I spent 80% of my time on considering models, building new models, testing them. And now the model creation part is a pretty small fraction of the total work. To run on a successful company, you have like many hats you have to wear, and only one of them is the modeling hat, right?
Yeah.
Like yesterday I was looking at office space, looking at renting an office, and there's just a lot of other stuff you have to do.
Yeah.
But as our company grows, then people get to specialize a little bit and wear fewer numbers of hats. And
Yeah. And what is the kind of biggest difference between working as an ML researcher versus working in applied machine learning?
I think the biggest difference for anyone is, as an ML researcher, your products are papers. Essentially, you're selling an idea, you're selling a story, you're selling a narrative. You're hoping it sticks in the market, and for it to stick means people understand it, and then hopefully they cite it later. It changes their own mind, it changes their own research trajectory, and you get in exchange citations. The metric is popularity.
Yeah.
In the other world, the more product-based world, you're selling products. Your products have to work. They have to bring value to someone, to some customer. The metric is revenue, not popularity. Like there's many successful companies out there that you've never heard of because the popularity doesn't matter to them. They make some widgets and they sell them by the millions and they make tons of money and nobody knows about it, right? It's just a different world. So I would say, yeah, selling ideas and papers versus selling products.
Yeah, that's an interesting way to put it. And do you feel the machine learning problem you're working on right now, someone who didn't have a research background like as you do can still tackle it?
Yeah, definitely. I think as the field of machine learning has matured, what's happened, right? So every year we get better and better tools that are easier to use, that require less background knowledge. We have people producing better and faster and easier to understand courses and tutorials and blogs about how all this works, so that it used to be in the 40, 50 years ago, you needed like a long gray beard, maybe many degrees, deep understanding of like all these parts of math to have anything to say about neural networks or machine learning and VC dimension and all this complicated stuff that people don't even have to learn now because they take shortcuts. So now you can have their high schoolers, actually an ML collective, which we haven't talked about.
Yeah.
We have high schoolers show up and present what they're working on. And like, I couldn't have done it. We couldn't. Well, maybe you could have because you're barely out of high school. But I couldn't have done this in high school because there were no tools. And now the tools are so good that anyone can train models on their own.
Yeah.
So you need less and less background to get into machine learning every year.
Yeah. I will definitely want to ask you more about ML Collective later. But now thinking about your background in research, I think we all have our own journey. It's not necessarily you spend 10 years and you don't have to have a PhD or 10 years of background in research to do machine learning. But looking back your journey in research, what is the most important thing you learned from that experience? How do you think that contribute to you being a founder today?
Yeah. I think you learn a lot of things as a researcher. Like if you do a PhD, it's 6 years of stuff and it's kind of full of learning. And only 25% of that learning has to do with maybe the topic that you're working on. It's a lot about you learn how to communicate, how to write, how to speak. But more importantly, I think you learn how to look at the world, figure out which questions you could ask that are interesting and not boring. And then you figure out strategies to answer them well and answer them convincingly. And then a key thing that I think some people learn and some people don't is to learn to ask and answer questions in a way that's completely disconnected from your own ego. So actually, this is a big difference between science and engineering.
Yeah.
In engineering, the question you're mostly asking is, can we build something that works this well? And then you answer it by building something that works that well. And if you don't, then you feel like maybe you've failed. You tried to build it and your latency is not good enough, or the memory is too much, or like there's so many bugs in the system, right? As a scientist, you try to ask questions, answer questions, and then you try to disconnect your ego from the answer so that you try to answer the question, and whatever the data is, you just look at it and you say, oh, that's curious. This works. This doesn't work. That's really interesting. Some people still connect their ego to the answer, and I find that they're not as effective as scientists. And I think one of the coolest skills that I see people often learn is the ability to kind of disconnect and have that egoless analysis of the data resulting from their experiments. And it's that curiosity that lets you really look at the data and figure out the maximum value from every little data point and see the whole story, like what the data is trying to tell you.
Yeah. If you were to restart your career, would you still make the same choices, doing a PhD, spend some time at Uber, and then start a company?
I don't know. Maybe. I don't know. It's hard question to answer. I would definitely still do a PhD. I don't know. I took a 4-year gap between undergrad and grad school and did a lot of stuff then, but I think I could have been a 2-year gap. I recommend, when people ask me, I recommend people to take at least a 2-year gap, because I find that some people that do undergrad and then straight to PhD, they sometimes don't know exactly what they want to do.
Yeah.
And more importantly, they haven't benefited from, say, 2 years of working at a company where you're paid a ton of money to have, in many cases, a decent manager that teaches you many skills that you don't have to learn on your own. You get paid to learn them. So better to learn that and then start your PhD like ahead a couple steps, I think.
Yeah.
Everyone's path is different.
Yeah. I didn't have a PhD, but I did do my master's degree right after I finished college.
Okay.
And in my classroom, I do notice the people who have some work experience, they're more motivated in studying. So for me, it's just like, okay, it's a continuation of my undergrad.
Okay.
I think the benefit is I have the momentum of like doing exam and studying. It's the same mentality. There's not so much adjustment. So I think that's the easy part. But the hard part is I sometimes feel disconnected to the reality, like what I'm like kind of deriving this probability distribution for. I just want to get done with this and then get a job.
Well, look at you now. I guess
hosting a podcast.
Yeah. Well, no, but you also got a job, right?
Right.
Several jobs. Yeah. Wait, what do you wish you did any part of that chunk of your journey differently?
Ooh, yeah. I don't know. I think I wish I would worked a little bit, but I don't think I would want to work for 2-3 years and then do a master, completely change my career. But I think if I had like 6 months to 1 year gap, just have a taste of the reality, maybe also make myself realize when you are in the industry, you don't have that much time to learn the foundational stuff. That might make me feel I appreciate the time that I can learn some math, derive the probability distribution, which I hated. I might actually enjoy doing that.
Yeah. I like what you mentioned about, I guess, either working or you're in school and you have time to learn the fundamentals. I wonder why we don't spend more time, or why it's not more common to have a job for 8 years and then as part of your job requirements, you're doing sort of continuing education and either backfilling fundamentals from other areas or learning new fundamentals that you didn't know before. Like, Seems like a good deal for companies to let their employees do that. I guess some companies do, but
Yeah, I think also related to different industry. Or if you're a doctor, you have to do some exam and stuff. But ideally, if I can completely design my whole work schedule, I would work, say, 9 months a year, and then just have 3 months of year I can learn whatever I want, and then just, cramp that time to master skill. I think that would be really cool. And then from research scientist to CEO, what is the shift of mentality? Do you feel you have to learn a lot of management skill? Do you feel it's challenging that you have to force myself not to give specific directions on the modeling part, to let go of something that you're very good at? Like, what was the challenge for you?
So first, at Windscape, the current company, I'm the CTO, not CEO.
Oh, sorry.
But it's like I said before, you wear a lot of hats, so I have to do a lot of stuff now that I didn't have to do before. Messing around with office space and signing up for so many random B2B SaaS platforms or something. But our team is pretty small right now, so we say 5 people usually, but it's hard to define how many people are really at a startup when you have people on the periphery doing random things, contracting occasionally. But yeah, 5 people is about the team I used to work with. So that part is not so different. And when we work on modeling problems, one of my really smart teammates, Sam, he takes a lot of his own direction and his own ideas and executes them in about the same way that some first author I used to work with would have done that on a paper. So yeah, it's not crazy different. For a big company, once you're at a company of 300 people and you're in charge of 300 or you're in charge of 50 or whatever, or 3, I think it's quite different then. But for me, for now, it's not so different.
Yeah. Do you miss writing papers and just immerse yourself in a research environment?
Yeah. I miss the purity of writing papers and this idea, the selling ideas, like I mentioned, is fun. It's more pure than selling products in some way.
Yeah. And going back to, if we were to start, are we going to do the same thing? I think a lot of people think, oh, you don't need a PhD to do machine learning, but I do see more and more PhDs, even before they graduate. There are some big companies reach out to them and then found their company. I see more researchers.
Yeah, I see some of those same people too, I think. I think when you're in the middle of a PhD, if it's a 6-year process and you're making $28K a year or $32K a year, and you can do an internship for a couple months and make about that same amount in just a couple months, it can be an easy decision to take the internship or take the half-time gig. Some of my friends did PhD technically at a university but also at Google Brain or something. What a sweet deal. We should all be so lucky to do that, I guess. As for startups, yeah, a lot of ML research has produced things that are, as opposed to other types of science, I think fairly immediately applicable. Not every paper, of course, but a number of ML papers have been fairly immediately applicable in industry. And then with some of the AI hype that used to be maybe more, and the VC dollars that were pretty free, then it was fairly easy to just get funding to start a company. I think it's cooled down a little bit in the last year or 2 or 3, but
yeah. Also seeing companies acquire entire lab of a university.
Yeah, when the whole lab has a expertise, and often that lab might be the undisputed world expert at this one topic, and that company really needs that topic, then makes sense.
So what made you wanted to start ML Collective?
Okay, ML Collective, different story. So at Uber, my friend Roseanne and I had a research group called Deep Collective. We were kind of like the deep learning, the neural network fundamental research group. And we would have our weekly lab meetings, group meetings, people present, just like a lab in academia, I guess. We would put out papers together, stay up till midnight the day before paper deadlines, all editing, collaborating, whatever. And by the end of our stay at Uber, we had a group that a lot of people liked a lot. And it was a decidedly good thing in people's lives and careers. And people just had fun. Some people published their first papers through this group. And then we found out we were all being fired and we were kind of all going our separate ways. And we thought could we just continue this group somehow? Would it be impossible just to make it something outside of Uber? Just pull the whole thing out.
Yeah.
And so we did. We just filed for a nonprofit, which was pretty easy. We renamed it from Deep Collective to ML Collective because when we workshopped Deep Collective with people, they thought it sounded like an underground cabal of Illuminati running the world and had nothing to do with neural networks, which was sad. So ML Collective is more digestible, I think. And then it also evolved over the last, I guess it's been 2.5 years. It started as just the research group we had inside Uber with the same sort of members. Whoever wants to shows up, presents papers, presents projects that they're working on. Roseanne ran at Uber a very successful reading group called Deep Learning Classics and Trends. That used to be a group inside Uber, and then we had a Zoom link that was available outside Uber, and now it's just completely external. So that kept going, and then we kind of just made it more open over time. So now it's essentially a group that anyone can join. We have a Discord. People show up there and have their own discussions. So it's kind of mutated from the original version. Now it's much bigger, much less organized, and much more amenable to people stopping by and kind of hanging out, investing a tiny bit of their time, whereas it used to be something people would spend a big chunk of their time. It's also really self-organized, which is just amazes me. So we would have these quarterly or so town hall meetings where we all get together and talk about how it's going. And after a couple of them, people would show up and say like, oh yeah, I started my own group, my own learning group for reinforcement learning or for NLP. And like we meet, we go through papers, we meet every Saturday. It's on, we have a calendar people can post events on. And like they just do it all themselves. And they wrote like 2 workshop papers. And a lot of these people are just getting into machine learning research fresh. So like this self-organized, just having a community, having people and energy and like shared knowledge, it has been powerful, I think.
Yeah. So it's a place for people to collaborate with each other, even if they don't work for the same company, for the same lab, they can collab.
We say it's like a lot of people getting into ML research, they have a natural research home, like they're at a university starting a PhD, and so they have a lab, and they have lab mates, they have a cluster, they have an advisor, a mentor. They have all the kind of surrounding stuff that you need to start to become a researcher. Some people have that in a company instead. Some people don't have that at all. They read tutorials online by themselves. They don't have lab mates. They don't have a mentor. They don't have compute. So for those people, we just try to connect them with all those resources that they might be missing. And we say we give them like a default research home, like some place that they can show up and just like go through the process of growing as a scientist, which none of those things I described, collaborators, mentors can be hard, but compute is pretty easy. Like none of the stuff I described is that hard to corral together and just set up and give to someone.
Yeah.
Mentorship is hard. It's hard to find mentors for people because it's a big investment of someone's time. So if any of you want to be mentors, send me an email. Send Roseanne an email.
Yeah. Have you ever received a piece of feedback that changed your perspective?
One feedback I got very early in my career is that I tended to be invested in things for their kind of technical curiosity, and I would dive into them until I was satisfied. Then once I was satisfied, I would say, "Oh, that's cool," and I would kind of like exit. And one of my bosses told me once that like things don't count unless you publish them, unless you communicate them with someone. So like maybe 8 people have made some scientific discovery, but if the 9th one publishes it, then the 9th one is the one that gets credit. But it's not even about the credit. The 9th one is the one that like brings that thing to the world, changes the world. So to have your work count, you need to show it, and you need to be good at showing it. You need to be good at communicating what you're doing. There's a phrase I like a lot, which is be loved or be hated, but never be misunderstood.
Yeah.
So like whatever you're communicating, it's always in your best interest to communicate it very clearly, and it's hard to learn that. It's a skill that takes years, whether it's written or spoken communication.
What are some resources you used that helped with your communication skills, or what are some principles you follow?
Yeah, there's like little tricks. Okay, one thing I hate is when someone spends months on a research project and then they're presenting and they have 10 slides or something, slide, boring, no data at all, and then boom, they click and slide number 8. It's like 3 plots, all these lines, all these axis labels, and then they just say like, it kind of works. Or something, and then they like move on, and it's like, no, you spent all that time getting that data. You should make maximal value out of every single pixel, every single data point on that plot. So one thing I like doing, and I've seen people do very well in general, is to animate plots. So you show the plot with just the axes labeled, you talk about the axes, you talk about what experiment you're going to run, and you say, so let's run that experiment. You kind of imagine your audience is running it with you right then. Then you click show the first line. So the baseline model, which is just a linear projection from A to B, works okay here. It works a little bit better in this scenario and that scenario, but it doesn't work too well. Okay, now what if we try this other model? Click show the next line. So now every single line means something to people. In particular, people perceive differences. So when you show an A and then you show a B, people immediately perceive any difference between A and B, and it intrigues them. If you just show A, B, C, D, E, F all on one screen, it's just a bunch of lines.
Yeah.
And like people don't understand what's going on. You can walk them through it, but if you're going to walk them through it line by line, which you should be doing, then take the time to do every single line separately. I've seen that work very well for many people, and every time people don't do that, or many times people don't do that, I think they're losing so much of the value of what they could be communicating.
Yeah, I think this is a great point. I'm probably guilty of that myself. I just plot 10 lines to get a different color.
Oh no.
And then you have this tiny like line to show them experiment 1, what did I do? And then even you yourself don't remember that, I think it's very important to take the time to walk through the process. And also, a lot of times after we finish training a model, we feel so tired. We just want to be done with it. We don't want to spend more time
You're so sick of looking at that model.
Interpret it. But just like you said, if you already put a lot of work in that, and if you don't take the last 1% of time to make it easier for other people to understand, you might not get buy-in from your stakeholder, and the entire effort might be a waste of your time. So so you said if you were to write a blog post about 10 things can help you be a better communicator or writer, what are some other elements?
Always having good baselines for what you're doing. If you just show numbers and like we got a 7, is that good or bad? Like no one can tell. You can't even tell unless you have something to compare it to.
Right.
Here's a naive baseline. We're doing much better than that baseline. Here's another baseline which would represent perfection maybe. And here's where we are in that range. We've covered 80% of the gap between something dumb and perfection. That's kind of meaningful.
Yeah.
So having baselines, showing those baselines, you're just making it really clear, always showing, A versus B versus C. Our thing is C. A and B are 2 other approaches, 2 other things we could have tried. This is just general stuff, but keeping in mind that no one else in your audience knows what you're doing as well as you do.
Yeah.
So you have to explain the basics, like maybe a little bit more than you think. Like you throw up your plot that you've seen like 80 times before, and you can just look at all 20 lines because you know exactly what you're looking for, but no one else knows that, right? So explaining the basics. I don't know how many conference talks I've seen where like 8 minutes in, I don't really know what they're doing or why, and so I'm not even ready to see whether what they did was good or not. Like I don't know what problem they're trying to solve because they never even mentioned it, because they've been working on the same problem for a year. So to them it's obvious, but like just saying the basic stuff, starting super high, super broad level, super high level, super broad, but then progressing quickly to your results. One random nitpick I have. Okay, one random nitpick is if you're giving a talk, don't have an outline slide, because nobody cares about your outline. Just do the outline. You don't need to show them the outline. Another one is from the start of your talk, there's this little plot. Here's time. Here's like people's battery, people's energy to listen to you. If you're famous, it starts higher. If no one knows who you are, it starts lower. Let's say it always starts a little bit above 0. And as you talk, you can do things that like make that bump up. People are intrigued or bumped out and they're bored. Once you cross 0, people like zone out and start checking in their emails. And it can be hard to get them out of 0. So you have to manage people's energy throughout a talk. So you start the talk, it's always a bit positive. You have a little clock from the time you start your talk. Every word you say that doesn't depend on any data at all costs something. Your line just goes down. Within like 45 seconds, 60, 90 seconds, you need to get to some slide that has something that depended on data. It can't just be your title slide. It can't be your bio. It can't be your picture of your lab, a picture of where you're from. It can't be your idea of a model. It has to be like something that someone could look at, and it could have been a different way. In other words, it's real data. So it could be your very first result. It could be comparing to someone else's paper. But if you get 8 slides into your talk and it's 7 minutes or something, and you haven't shown a single thing other than your ideas, then you've lost people.
Yeah, that's a really good advice. I think a lot of times we forget about our audience. They don't have any background where we're talking about. Even if you're in a meeting with your VP and director, you think, oh yeah, they're very smart, I don't need to explain the basic things. But imagine they probably go to like 10 different meetings a day. They're constantly switching the context, and you do need to remind them the basic, why you're doing this, the context, make it easy.
Totally. Yeah.
And previously you talked about the ML toolkits is different today. It's so easy for people to get into machine learning, deep learning. So what are some shifts in the tools we use? For example, what are some new ML frameworks or package you see more people are using? What are something you think is gonna be retired?
Yeah, I mean, there's so many packages, and then over time, the evolution we could talk about. A couple high points, though. So first, the availability of compute. You can now just rent a computer that is going to be good enough for you very easily. That didn't used to be possible. Actually, we now use GPUs commonly to train neural network models in particular, but that also didn't used to be possible. You used to be an expert. Either you use CPU only or be an expert in like shader libraries and like the original CUDA code that was possible to use, but it was kind of a huge mess. Neural network libraries, so PyTorch, TensorFlow, JAX, whatever. I'll tell a story that reveals how old I am. So when I started grad school, there were a couple libraries, but I mostly didn't know about them. So I started using just straight NumPy to code neural networks.
Oh, wow.
And I wrote my own library, and it was ugly in all the ways you can imagine, and some that you probably can't. Anyway, networks have an input, and then there's some like matrix multiply, and maybe some nonlinearity, maybe some regularization, normalization, maybe some more matrix multiply. And I was so dumb when I started. I didn't really think that a layer should be like a matmul followed by a nonlinearity. I kind of thought about it the other way around. Like first you take your data, you apply a nonlinearity, and then you do a matmul. And so I wrote my own library with layers, but the layers were all reversed. Anyway, if you're getting into network, you don't have to think about this. Someone already made this decision long ago. It's the other way around. So we have the libraries, the compute. There's more data sets than ever, I guess. Yeah, I would say, and there's also like web, like things to track results. Like Jupyter notebooks are beautiful, super easy to use and share. Colab is very nice, built on top of that. Actually, in ML Collective, we give out compute to people. We have some grants that we get where we get a grant from a company, and then we try to allocate chunks of that grant to people. And it's kind of ugly and complicated. That would be great if someone could solve that. But instead, people just use Colab mostly, and it's so much simpler. So like that, having a GPU at your fingertips literally for free is really cool.
Yeah. And for machine learning practitioners today, what do you think are the most important skill sets?
I mean, maybe the most important one is just being a good coder. So you're going to have to write code, and either your code starts falling apart after, 2 pages worth of code, or after a dozen files and many pages, 1,000 lines of code, right? So learning not only how to write efficient functions, lead code, algorithms, and all that, that's like the very first layer of being a good coder. The second or third layer or something is being a good software engineer. So seeing how the whole system fits together, building a system that's maintainable, that encapsulates complexity correctly, allowing it to be extensible later. So figuring out what you can build now that you could change later and add to later. It's hard. Like it's not an easy skill to learn, but it's important, and the people that are great at it are far more effective for it, and they're far more effective ML practitioners, not just programmers. You need to be a scientist, like I said, and ask and answer questions in an unbiased way. A good understanding of linear algebra helps a lot, which not everyone has, and also a good understanding of probability and statistics. If you get closer to kind of data science, which is in many ways a neighbor of ML, and in many ways what pays the bills for ML, you need to know about like doing proper tests of things, doing proper controlled tests of things. Yeah, maybe that's it.
And so now, what do you think about the future of machine learning?
The future of ML. So I kind of see, it's a big question, and there's so many ways we could answer. One reason it's a big question is because I think ML will just pervade more and more of society and job functions and companies. So I see ML taking like a sort of similar trajectory to what like programming took, but maybe 20 years later or something.
Yeah.
So maybe in the, I don't know, mid 90s or something, you would start a company and you might call it like a programming company. And you would ask what they did and they say, well, we use programming to accomplish something cool, right? But now it's just assumed every company is or many companies are programming companies. Google's not a programming company. It's not Salesforce is not a coding company, right? These are all companies that accomplish something specific. And the fact that they use programming to help them accomplish it is taken as an assumption. So I think ML's on a similar trajectory. So in another decade-ish, ML will just be, there won't be AI companies, ML companies. Our website is windscape.ai. I think it's already declining in popularity. Like there'll be no reason to use a .ai domain name because every company will be an AI company. It's just like, well, what do you do with the AI? What do you do with the ML? So that's one factor I think is it becomes more commonplace, and that's supported well by the fact that it's becoming easier, which allows us to have a much bigger workforce and allows the next 100,000 people starting their careers to be not necessarily AI experts, but like AI competent, programming competent, and also maybe good at some other things. But it's just like a standard part of the tool belt that everyone will be expected to have. So that's a factor. What else? Models will continue to scale. Even though we've all known that models will continue to scale for a while, I have been still impressed. In other words, compared to my previous expectations, I'm still impressed with what people have managed to do with some of these large models.
Yeah.
The image generative models, text generative models, right? Like DALL-E, ChatGPT and all that. How will that change society? I don't know. There's a lot of applications, think of the data you produce every day or consume every day. We're now recording a video, but most data that you consume every day, I'm guessing, is text. So you read text like a high fraction of your day. Email, websites, company docs, I don't know. You produce company docs. So much of our world is already back and forth text that obviously text is like here to stay. And if we can have models that understand text very well, they can just fundamentally change our relationship to like over half of our interactions, over half of our life. So it's hard to predict exactly what direction that'll take, but I think it'll be big. What else? I think ML is also one mental model for ML is it's generally cheap to do inference. So let's say you train a model to do something and then you deploy it and you can run it 100,000 times a day, 10 million times a day if you want, and it's not too much money. So ML is great at providing value when you need to provide a very high volume of decisions that are small value each. And we've already seen ML deployed to tweak ads that are being shown to millions of people and then slightly increase the expected value, right? So in general, anytime there are high volumes of decisions that are low value each, you'll see ML deployed. When there are low volumes of decisions that are high value each, so for example, you deciding which new apartment to move to, we might have ML like help you visualize something, but ultimately you'll probably make that decision yourself. Right. Like humans will still make the lowest volume, highest value decisions themselves, I imagine, for a while. Yeah. I don't know. What do you think? What directions do you see? Any big patterns you see for ML?
Well, I haven't done a lot of like research on that. I can give you maybe just from a few data points or my intuition. I agree with you. I think in the future, everything AI is a default. So now you can market some coffee or I don't know, coffee made by AI is something cool to do. But in the future, maybe, coffee made by a human. The human thing might be a cool thing to do. You have to specifically label that. And I think a lot about like what does it mean for data science or machine learning engineers. I think maybe in the future, machine learning may be just a skill set for software engineers. And also with a lot of auto ML, ML ops tools. I don't know if the specification of ML engineers still makes sense. I could be wrong. Like and I don't think data science is going away. There's still a lot of needs, for example, like you mentioned, to do experimentation, to understand a lot of like causal inference, to understand metrics, design metrics. I think to understand a business use case, I think that's still going to be very important. I think there's going to be more and more tools. The tools is going to be less important. It's more like, how do you approach a problem? How do you solve a problem? How do you decide what kind of problem are important to solve? And I think service industry is interesting. So I think a lot about the human factor of it. I think in the future, maybe we're going to be more efficient, but maybe we'll become more lonely with remote work or all different technologies. And if there's something or like some community will make people feel more connected, I think that's something exciting.
Yeah. I mean, I agree. If ML tools or models or whatever could help us with human connection, that would be deeply meaningful, because that's a long-term problem and value creation possibility that's been around for thousands of years, right? It's not a problem that's going anywhere.
And what is something in your career or personal life right now you feel excited about?
I have like too many hobbies. I'm always like picking up new hobbies and then not finishing the old ones, so I don't know. Making art is fun. Sailing is fun, but I haven't sailed for a while. I've been to paragliding, but I haven't flown for a little while because I got busy. I don't know.
And you just got back from a personal development retreat or workshop. Would you call it personal development?
Yeah, sure. So I did, like you're alluding, I did this thing called like the Hoffman process, which is it's like a 1 week personal development, maybe retreat. It's been going for, I don't know, 50 or 60 years. Like, it's not a new thing. The center, there's 2 in the US. One is in Petaluma, which is by us in San Francisco. And there's one in Connecticut too. It was an intense week. You just go, I don't know, everyone should try this program, I think. It's probably valuable for most people. You go pretty deep into patterns of being you learned from your parents, especially relatively early in childhood. Like, how did your parents treat you, and how does that affect who you are today? Sometimes they act a certain way, and as a young child you learn to copy them so you can be like them so that they'll love you. We do that with many things. A smaller percent of the time, maybe your parents do something that really bothers you or offends you or traumatizes you, and you decide as a 3-year-old or as a 12-year-old or something, I'm never going to be like that. And you decide to be the opposite. And so you rebel against that pattern. You try to be the opposite person. In any case, both of those, the Hoffman process would hold that both of those can be compulsive patterns, meaning it's a way you react in the world that's automatic and you don't think about it. And they would hold that you're better off if you can think directly about how you're reacting to things and make conscious, more intelligent choices about what you want to do in reaction. So if you're constantly anxious, maybe you should stop, realize you're anxious, think about why, identify that it comes from this factor, and then identify that it's in fact your choice to be anxious or not. And take a deep breath and maybe decide, I think I'll not be anxious right now. That sounds like trivially or like too easy, but in fact, sometimes just stopping and thinking about things differently can be enough to change an outcome.
It's like we get programmed consciously or unconsciously when we're kids, and then we're just running that pattern over and over again. And at a certain point, you realize those patterns don't serve you anymore, and then you need to put some effort to unlearn those patterns. I like to use the analogy of like recurrent neural nets. I think it's pretty smart. It has the forget gate. If you think about humans, we don't have the forget gate. We just always carry that piece of information, especially I think first impression is kind of a huge bias we have because people change, but when we meet someone new, the first impression always carries with us. Sometimes we forget to update, okay, this person changed, this relationship changed, but we still hold down the piece of
that first impression. Man, that's a lot of pressure. Realizing how important first impressions are. What about alcohol? Isn't alcohol kind of like our forget gate?
Alcohol is like a temporary forget gate.
Oh, yeah, it's only temporary. Right. Good point.
And also, I think sometimes it's really helpful if we can just forget about certain things. And do
you think that's coming? We'll have Neuralink and like targeted forgetting, like zap this memory, please.
But then you're using those tools or devices. Who's deciding which memory you should forget?
Well, it depends on your subscription tier.
Like what is the metric you want to optimize?
600 per month plan.
And also I think now when I think about it, I think when we were kids we were very sensitive. Our parents, I don't know, I think for most people, our parents are nice to us most of the days. But on the days when they are angry, we probably amplify that data point, and then we kind of remember the day our parents react to us. So sometimes I feel it would be nice if we can put an appropriate amount for all the days, so we don't take our parents for granted right now. Because sometimes I think about, oh, my mom like cook for me like breakfast every morning, but in my mind it's such a weak data point. You know, I just take it for granted.
She did cook every morning almost,
yeah,
but you barely remember it.
But I barely remember. I remember the big events we did together, happy or sad. But those might not be a real representation of a memory. It would be cool if I can visualize those data points and, you know, because most of our memories are wrong. Yeah.
That's a good point. Yeah, maybe...
If we can visualize that, maybe it can give us a more realistic perspective of our programming.
Yeah, or if we could like track our whole lives or something.
Yeah.
But I've seen some. I feel like Black Mirror is on that. Like, does that actually make us happier if we could track everything, go back and see what really happened? Would that make you happier, or are you happier with the fake picture you created in your mind already?
Oh.
I don't know.
I think our brain the reason our brain create a fake picture is to make us happy or protect us, to amplify the sad or
So don't rock the boat.
Angry. So maybe
let's not rock the boat with careful childhood data science.
Right. Maybe consult the neuroscientist to build a visualization. So I'm happy with the lie, whatever my brain creates for me right now. Yep. So sometimes I think about those type of things.
There was some professor I remember that had a kid during year 4 of his professorship or something, so of course decided this would be a great time for a new project, which was record everything the kid experienced for the first 2 years. So like many cameras and microphones around the house.
Wow.
And I think it was filtered and then made public, the filtered part or something, but it'd be interesting to analyze that kind of data.
Yeah, like if I am able to analyze my own data, I would be curious to see what did I actually experience.
But like, I don't know, do you have like some Aura ring or like these sleep tracker things?
No, I don't like to have devices.
Yeah.
I just...
Same.
Yeah.
But even if a device aside, do you think data about your sleep is valuable?
I think it's more like a mindfulness thing. I know I'm tracking it, so it's like a reminder for myself, oh, I don't want to see the bad sleep data, so I go to bed early. I think it's like a little nudge thing. Yeah.
That sounds useful, actually. I haven't really tried, but that sounds useful. Some of my other friends have their sleep tracker, and I feel like they're constantly stressing and showing me like, look, my sleep was bad last night. And like, I would almost rather just not know that.
Right. It's like A/B testing. It's like the early peaking thing. It's not helpful if you peak the experiment data every day. I think you should batch it, look at it every 3 quarters, every 3 months or something.
8 years later. The reason you were tired for 8 years is your sleep was bad for 8 years. Yeah.
Yeah, exactly. I don't want to stress out over the small things. I don't want to look at my metrics, and I think a lot of things is not linear, and then if you get stressed out by those variation, I think you're letting those noise kind of dictate how you feel throughout the day. I think a lot of times we know, just sit there, feel, are you feel stressed, ask ourselves these questions, and I think we're smart enough to have a sense of those things. It doesn't have to be reflected in numbers.
Yeah. That's a good point. That's a good point. I feel like if anything, we need, I don't know if sensors would help, but we need maybe better tracking for like the things that actually made you happy in a day or caused you stress.
That's something called journaling.
Yeah, it is kind of, right?
Yeah.
Like if you can track not annoyance variables or like noise, but track the real things, the real cause and effect relationships that make you happy or sad or something. Like, I would like to see that data, because that would probably show me things, or show all of us things that we didn't realize. Like, oh yeah, every single time I see this friend, I'm happy for 2 days afterward. I probably don't have the correct like time window view of the world to understand those relationships very well. My brain is like, if I do something right now and my finger hurts immediately after, I know that I just burned myself, but it's like only short-term explanations.
Right.
Yeah.
Yeah, that's a good point. Like if I had chocolate a week before, and then that contributes to my happiness at this moment, I kind of want to know that.
Yeah.
Cool.
But credit assignment is hard. Like as time extends what there's like exponentially more things to possibly assign the credit for.
Yeah.
So it's a hard problem in general, right?
Yeah. So do you have a blog or for people who are interested in peeking into more of some interesting thoughts from Jason, where can they find you?
I don't have a blog. I have a website that has some papers and stuff on it.
Yeah.
But no, not really.
Okay. Oh, yeah. There's a lot of interesting visualization of the talks. If you're interested in what we just talked about, how he tried to understand neural network, you can find it on Jason's website.
Yep.
Yeah, I'll link it in the show notes.
Yosinski.com. And me saying that will in no way help anyone find it, but maybe in the description.
Yeah, I'll link it there.
Cool.
Before we wrap up, anything else you want to tell the audience?
Well, I did not prepare anything, but thank you for having me on. This is really fun.
Yeah.
I don't think I've recorded anything like this before, and it was fun just to sit here and talk about random stuff for an hour and a bit. Two things, I feel like two things have served me well for many years. One is if you're choosing between multiple things that you could do or work on, and you're not sure what metric you should be using, and there's like a balance here and there, just using the metric of what seems most exciting to you has served me very well. Like a lot of times I've done that. I'm like, I don't know if this is going to work, but this seems really exciting, and I just do it. And like it does end up paying off later.
Yeah.
I think that's one thing I wish I tried to live by and wish to live by in the future. Yeah, I'll leave it at that actually. Yeah.
Okay. Yeah, perfect. I could use that advice. Yeah, right now. Awesome. It was great to have you on the Data Scientist Show, Jason. I love your fashion today. And yeah, if you like the show, don't forget to subscribe and give us a 5-star review. Bye.